First of all, there's a few changes I made, which I will talk about. Basically just lifestyle changes because I realize I need to put units on all this stuff, which is going to be a pain, but I will slowly add units. Some easier than others. Yes. Generally speaking, what I have basically I realized I'm near the 550 page again, which means I'm gonna have to shorten things again because I want the book to be 550 pages. That's my initial thought. But then I realized, do I really need to keep that limit to myself and move it to book two? I'm not sure now. I'm rethinking that. Because it might be easier just to, but then again. I don't know. I'll decide soon. Because I have a feeling that a lot of this can be shortened. Anyways, um, especially since I keep on talking about these cases. Case one, case two, and then case three over here. I keep on doing that one. So we might actually be able to just get rid of all that and not deal with that soon. Um, yes. So yes, last time I just talked about all these basically basic ODE questions are second order linear and gave real life examples mostly, but they're idealistic as always. Um, yes, they're real life examples, although so they work. And then I realized I don't have any negative examples, so I went in here and found example that is negative because all these are positive. So by that I mean if you move it to one side, it's all positive, which is true for all natural, basically all natural systems, basically that decay over time and stable and loses energy. So I mean, not always lose energy, but you get what I mean. So I need to not lose energy, sorry. More like what's the right word? Because this loses energy too. What's the right word? It's stable. It's stable, which means it will go to equilibrium point over here in the end of the day. Basically, it goes to zero always. But this is the first one that will explode. Why this explode? Is because this cannot go back to the center without some electrical control box. And I also changed this to get rid of the human because I have a better question for that one later. This is a mass and ball. This is the equation for it. This is very simplified, but it works. But this is valid because as soon as the control works, we use this ODE because we only need to be valid for 15 degrees because after that, your control is not really working. So, and then you can eventually get this thing to stand right up in the center, which is cool and awesome, but that takes a while. Anyways. That's all control theory. That's a lot of control theory. Anyways, non-linear, you have to use a bunch of stuff, which is, you know, powerful in itself. You can figure it out and like finally figured out some parts of it with using these ideas over here. But eventually you get that. This is one of the classic questions that you can get when you first learn non-linear stuff. Anyways, and then I do bring in Arctan over here because that to me is one of the core moments, like, Arctan 2, those things are. Anyways, now we finally have another negative thing. Now, here's my conundrum a little bit. So, what I'm going to do here is that we have a negative thing over here. This is an active damper, which means you have a lot of motor systems and a lot of unstable active control to make this. But eventually, you realize that the warning this model will break. They'll break because if you model them, you'll realize that if this is true to happen, this active thing happens, it will explode. Don't break. So it's non-physical, and why would you make this machine? So each time you do, I mean, there's certain cases, I guess you can make a buckling system, but then you'd use Young's modulus actually. Maybe there's a Young modulus thing I could have done like this that would actually indicate a break. Never thought of that, but yes, actually, this can actually probably model Young's modulus somehow. Um, that's basically material property to break. I never thought of it until now, but it could probably do that somehow, some way. I don't. I mean, I need to think about it. Now, here's the reason why I didn't want to do that because there's another inversion pressure I'm making, which has a more general version of inverted pendulum with a mass that is kind of obtuse and unknown. Like that, you're just gonna have to find it numerically. And then you have a B, which is gonna be the fluid over here. and you're gonna have a negative here. Why this negative is important now is because we have finally have a negative thing, which is gonna indicate so much more for us because now we have a second order. Now, I'm going to also make another question where we have an active component over here that makes this negative over here. Why is this important later on? I didn't do this later. I'll do this later. Well, finally, we have a negative negative. Why then? Because over here, if you have a negative over here, you can make this positive positive. Basically, you already have that number, have the equation solved if you have a, theoretical negative that thing, because I don't think you can get a negative in the moment of inertia. This J is moment of inertia, basically of density kind. Um, so it's this mass kind. So basically, what I'm saying is that we can now formulate every single type of linear ODE with physical examples. So after that, you don't really need to think like, is this anything realistic? We have all the realistic answers. So. That's what I'm planning to do. Unfortunately, the biggest problem hurdle I have right now is the page number. The page number is pretty going insane. I'm thinking of going backwards, but I don't want to go backwards. So what I'm going to do is just continuously push forward until I finish all this, and then go to book two. And next year, in the next year summer or winter break, I will look at this all over again and fix it. I think winter break, I'm gonna have to work on my capstone project. So probably not winter break, probably with summer break, where I look back all of this and next year, that means, and go back from section one to all section seven and then boop, clean it up. Because there's a lot of sections here that are, what's the word, bloated. They have too much stuff that are not, and they have, I want to pack as much dense information as I can into a subject. So, with no fluff, minimal fluff. I don't want too much fluff here. Uh, Therefore, I need to make that happen. And I think there's too much fluff in my textbook right now. Basically, there's so much empty space. And what I'm talking about is basically when you look at something like, I don't know, this is fine. This is good. This is not good. You see how there's fluff over here. This thing over here is all fluff that I can be using, but I'm not using because I didn't think of it at the time. So next year I'm gonna clean that up and use this space like it was meant to be, and that's the plan. And when I have time, I'll do all that. And yes, there's a lot of fluff questions. Anyway, this question actually I could delete probably. So this Taylor series, I don't really like this question. Yeah, no, this question definitely stinks a little bit. Yeah, this work, I did all this work for nothing, I think. And that will save 3 pages. And I can keep this part. Yes, beautiful. And then this part, I believe, has an enter. Wow. Yeah, so I'm also deleting all the confusing, ridiculously, like, what's the point of that question? I'll only put questions that have a point to it. Um, there's a reason for it to exist in real life. Like, you can actually see it in real life and say, yeah, I could use that in a sort of situation. If in a sort of situation that you might be finding yourself in. If that is not there, we'll delete it. And that was one of the ones I think is no longer no point in that question. So if you find a question that you think there's no value in, we can delete it. I will delete it. I will always delete questions that are shit, basically. Um, yeah. Anyway, that saved me 3 more pages. Yeah, there's probably a bunch of that here, but these are good questions, I believe. These are this needs to be cleaned up. There's too much empty space over here I can use. But yeah, these are great questions. Like this one, awesome. Like this one definitely is useful. Has useful elements to it that can be used. This one definitely clear, clean, clean. Yeah. So this is kind of the format I am good with. So yeah, I will change everything to that format next year probably when I redo all this stuff and make it cleaner. Um, yeah. Mm, yeah. Yeah, there's a bunch of that I need to think of, and we'll clean it up. Now, I just realized how confusing sign with I is because think about it as a new person, you'll think, why is there why is there a magic number and sign or something? Because the only reason I can tell a sign is because my eyes have been more trained to intuitively realize that it's sign with an I, and that's not always true. So I might need to think of a way to indicate that. Anyways, I'm done now. I'm done with my recording. Hopefully, it was intuitive enough for you guys to understand everything. I mean, there's a lot of examples. I mean. In reality, the map explains itself once you actually read it. Oh, here's another thing I'm gonna. Once you look at it, it's just straight down. Like there's no real. I mean, it's kind of I think it's straightforward, uh, but maybe I need to put more writing in it. But we'll see. I don't think there needs to be more writing because after that point, it's more fluff than anything else. In my opinion, a lot of the text has a lot of fluff in it that shows blah 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 blah. When I don't need that stuff. So this is what I have clarified and cleaned up to this extent. Um, Hope it was good. I'm not sure yet. Maybe I need to put meters. I definitely need to put meters on all this stuff. Yeah, maybe that. Anyway, I think I'm gonna stop recording.